All right, let's get into infinite limits. It's going to be one of the more challenging sections because a lot of the problems require that you know what a function looks like. Through your homework, they do a pretty good job of just giving you graphs and then you making decisions from it. But as we move forward, it's going to start being that you need to know what these graphs look like in order to answer any of the dang questions, or you just got to be pro with domain. You know what I mean? If you understand all your domain restrictions, that shouldn't be too bad. So let's get into infinite limits. And the way we describe infinite limits first is we got to go back to algebra, just like with everything. And we got to start discussing a vertical asymptote. So a vertical asymptote is a vertical line, x equals a, or x equals 0, or x equals 5, or whatever. It's a vertical line, straight up and down, such that the graph of the function approaches as x approaches that number. Well, that's a lot of frickin' words, but hey, that's problem number 2. That's problem number 2 in your homework. You should know that one. Okay, moving on. Let's give some examples. Hey, here we go. I got 2 fancy functions. Sorry about my dog coming in with his long-ass nails. We have 2 functions here. We have our first one, 1 over x, the reciprocal function. That is a parent function, one that not knowing how to do, especially once we get into 2.5, I'd stop what you're doing, make sure you know what that looks like before even moving forward, because that's going to pop up over and over and over in this class. Not knowing how to graph the reciprocal function, good luck. Just good luck. So we go through and we look. It's like, hey, right, we're not allowed to divide. Oh, shoot, wrong button. We're not allowed to divide by 0, right? That's really bad. So that's why we have an issue here at x equals 0. That creates a vertical asymptote, right? As our x values get closer and closer to a, our y value, at least from the right, blows up to infinity. And if we take our x values from the left and we get closer and closer to 0, it looks like our y values are going down to negative infinity. That's what happens at vertical asymptotes, right? You can't pass. It's almost like this little force field. So that's 1 over x. Oh, actually, I'm sorry. Dude, I can't believe it. I just wrote it wrong. I don't want 1 over x. I want 1 over x to the 5th. No. I don't want 1 over x. I want 1 over x to the 51st. Same graph. I mean, it's a little different. The shape would be different, but the vertical asymptote would remain the same. It wouldn't matter. You're still not allowed to divide by 0. Oh, you know what? I got it wrong again. It's the 513th. No. The 5,137th. Do you notice I keep writing an odd number? Okay, cool. And that's that graph. So it could be 1 over x cubed. But I'm just going to leave it as 1 over x. Cool, but it still has a vertical freaking asymptote. It doesn't matter what power we raise it to. Shoot, I can even change this 1 to a 4. It's still basically the same thing. The only thing that matters is we're not allowed to divide by 0. Okay. Now let's look at the graph on the right, and I think you can see something different. It's not quite the same. If you look at the left, it's on the positive y part, where over here we were on the negative. And why is that? Well, it's because this can take on negative numbers. But when we come over to the 1 over x squared, what happens when you square a negative number? It's positive. Neat. But it still doesn't make any difference. If you pop in 0 in for x, we still have an issue. You're not allowed to divide by 0. So these are our vertical asymptotes. Just a couple of examples. Trust me, we'll have a lot more. So let's go through and start talking about our limits. And this is what we're doing in our section. So let me write it down. Let's look at the limit as x tends towards 0 from the left of our f of x. And I'll write it in as 1 over x. So we look and we're like, well, from the left, this one goes to negative infinity. Right? That's where the y value is heading. It never achieves it because it's a number. But that's where it's going, and we're describing where it's going to head to. And then we can take the limit as x tends towards 0 from the right-hand side, and we look, and we're like, well, so we're coming from the right. This is going to blow up and go up to infinity. So it's positive infinity. And now I ask you, what would be the limit as x tends just towards 0? Not from the left, not from the right. So we look up and we go, does negative infinity equal positive infinity? Absolutely not. Those are two different things. So we would write does not exist. There's no limit. But from the left, it has a limit going to negative infinity, and from the right, it has a limit going to positive infinity. Can you see what's going to happen with g of x when we mess with this one? So when we take our limit as x tends towards 0 from the left-hand side of 1 over x squared, or 1 over x to any even power, and we're going to find that it is equal to, let's see, from the left, it goes up to infinity. And we take the limit as x tends towards 0 from the right-hand side. And again, we can see that it's going up to positive infinity. Oh, that's good news. Oh, shoot. So when we go to do our actual limit, not from the left, not from the right, we really don't care about those lefts and rights, only to say that we're getting the same dang thing, because we really only care about the ones on the bottom. And we look and we're like, hey, positive infinity is exactly the same thing as positive infinity. Thus, our limit as x tends towards 0 of 1 over x squared is equal to infinity. That is our infinite limit. So, the one on the right, or the left, does not have a limit as x tends towards 0 because of those dang odd powers. They're not going the same direction at that vertical asymptote. But the one on the right, since we have an even power on that x, we're finding that it's going to positive infinity and its limit truly does exist. So this is the beginning. I'm going to start putting in, the next one's going to be kind of funky for when you don't know what a function looks like. And then we'll talk about some of the trigonometric functions that most of us have forgotten about. So I will see you in the next.